Hey y'all, welcome back. In this video, we're going to be looking at how to combine, that is add, subtract, multiply, divide, two numbers in scientific notation. Let's start with addition and subtraction because they're fairly similar. Uh, when you have two numbers that you are trying to add, say these two, right, you need to be careful of what your powers of 10 are. Let's first talk about what not to do here. We have two different powers of 10 here, and so you're not actually allowed to combine these two. We can't take the two coefficients, right, and then just kind of smash them together to be a new number, and then somehow smash their 10 to the exponents together as well. Think of the 10 to the fifth and 10 to the sixth as like different units, like grams and kilograms. Right? Imagine this is 2.451 grams and 2.45, or sorry, it's 9.92 kilograms. We wouldn't be able to just add these two numbers up, right? We need to first convert the units on these, so to speak. We need to make sure that these have the same power of 10 before we can combine them. Just like we would want to make sure that we were adding grams to grams or kilograms to kilograms on one of these unit problems. So let's talk about how to do this. We're going to try to convert the 10 to the fifth to be 10 to the sixth, right? We want these to have the same power of 10. And we're going to try to make the one with the smaller exponent match the one with the bigger exponent. So we want to rewrite the first number to have a 10 to the sixth power, right? So if I'm thinking about how to do that, I see that I need the 10 to the fifth to become 10 to the sixth. That is, I need the exponent to go up by 1, right? That is, this number to get bigger by 1. Right? That means that I need to move this decimal place over 1 to the left, right? Because that's going to make this number correspondingly smaller, kind of like we did at the end of the last video when we were looking at numbers that were not quite in scientific notation. Right? If I move the exponent up 1, that means I'm going to move my decimal place 1 to the left. Okay? So this is my new way of writing this number. It's no longer in scientific notation, but that's okay. It is as it needs to be for us to combine it with the other number that is written as a power of 10 to the power of 6. So now we can add these two together just like we would like to. They have the same power of 6, so we can actually put these two coefficients together to get 10.1651 times 10 to the 6th. Okay. We're not quite done yet, though. Okay. There's two things we need to do. One of them is we notice that this is not in scientific notation, so we need to put it back in scientific notation. But there's something we need to do before that. Normally in this class, I'm not very picky about rounding. I wouldn't generally take off points for rounding unless it was just absolutely egregious. But here, we're going to need to be a little bit more careful. Remember that all of these measurements in scientific notations are right. Imagine some measurement in physics or biology or chemistry. It has some measure of precision associated with it, right? If you're measuring weight or mass or temperature or distance, you can measure out to a certain number of decimal places in terms of precision. When we are adding, subtracting, multiplying, dividing two numbers in scientific notation, we have to keep the precision of those two numbers in mind. We don't want to combine the two numbers and then lead our reader on to thinking that it's more precise than it actually is. Right? So we're actually going to take the less precise of the two numbers and let that dictate how precise our answer is. Let's go back to this example to explore what I mean by that. So here was the example we just went through. Right? At the end, we got 10.1651 times 10 to the 6th. Looking at this 9.92 here, right? This was measured out to the 100th place. We don't actually know whether this number is in reality 9.9200, 9.9201, 9.9210, right? We basically only measured out to the 100th place and then didn't measure any farther than that, right? So the problem with saying that the sum of these two numbers is 10.1651 right, is that kind of implies that we know that the 9.92 is actually 9.9200, right? And we don't actually have that knowledge, right? So what we're going to do is we're going to say that, okay, this resulting number is going to have the same level of precision as the less precise of these two numbers. And by less precise, I mean the one that has fewer places after the decimal place, right? So in this case, we go out to the hundredth place here, right? And that's going to be the shorter of these two, right? This one goes out 4 places, this one goes out 2 places. Right? So we're going to round this final answer, to be 2 decimal places. So it'll be 10.17, right? The 6 being bumped up because of the 5-1 after. Okay, and then after that, we're going to put it in scientific notation. We need to move this decimal place over 1, right? Because right now this is not scientific notation. This number is not between 1 and 10. So this needs to be moved over 1, making this number smaller. And so we need to bump this 6 up to a 7. Right? Final answer, 1.017 times 10 to the 7th. Okay, and that's it. So just to recap that algorithm, right? If you are adding or subtracting, I know that was all for adding, but subtracting is exactly the same. You're going to put the 2 numbers in scientific notation, convert one of those numbers, the one with the smaller exponent, so that it has the same power of 10 as the other number, the one that has the bigger exponent. Then add them, then round in the way that we just described, then put it in scientific notation. Remember, rounding here means you're going to round it to the same number of places that the less precise number had of the 2 numbers you were adding. So try your hand at these 2, right? And pause the video and write your response in this survey. Okay, this should be what you got for the first one, right? You have a 10 to the 3 and 10 to the 4. Right? In order to add them, we need to convert this number to be a 10 to the 4. That is, we need to increase this exponent and then move this 1 place to the left, right? Then we can add them, right? We'll get some 5.92, blah, 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 right? That's going to be much longer than this. But then we see that of our 2 numbers, this number has the fewest places after the decimal place. And so we will round to the same number as this number, just 2 places here, okay? For this number, this one may look a little bit strange to you. Notice we took 8.311 times 10 to the 15th minus 4.23 times 10 to the 9th, and we got back the same number right here, which is as the first number here, which is kind of weird. Right? The reason for that is because this number is so much smaller than this one that when we actually subtract this from here, because of the way that we're rounding with the significant figures, this number is so much smaller than this one that it actually doesn't even make a dent in it, right? And that's, again, purely because of the way that we are rounding with the sig figs, right? So don't be alarmed if you add or subtract 2 numbers and you end up getting basically one of those numbers back. Okay, now let's talk about multiplying and dividing. This is actually easier than adding and subtracting. So let's go through an example. 1.25 times 10 to the 18th times 9.3488 times 10 to the negative 3rd. Remember that with multiplication, you're allowed to move around the numbers however you want, right? I could take 1.25 times this number, times this number, times this number if I want, right? So let's do just that, right? Let's take this number and this number together, and this number and this number together. Okay? Now this is a lot easier. We can just add these, multiply these 2, right? And hopefully you remember your rules for multiplying exponents. If I multiply 10 to the 18th times 10 to the negative 3, then I'm actually going to be adding these 2 exponents together. So 18 plus negative 3 is going to give me 10 to the 15th for my power. Right, so here's my scientific notation. Again, we are not done yet, right? We need to put this in scientific notation first and then round. And this is the difference I want to highlight between multiplying and dividing versus adding and subtracting in terms of rounding. When we were rounding for adding and subtracting, right? Here's what we did. We did the addition or subtraction, then we rounded, then we put in scientific notation. If you're multiplying and dividing, you're going to multiply or divide, then put in scientific notation, then round. So the last 2 steps are actually flipped if you are multiplying or dividing. right? So in this example here was as far as we multiplied, right? If we had been adding and subtracting, we would then round and then put in scientific notation. Since it's multiplying and dividing, we're actually going to put it in scientific notation. And then we're going to round, right? We're going to round to, again, the less precise of the two numbers we started with. We look back here at these two numbers in the scientific notation, right? One of them has 2 places after the decimal place. The other one has 4. We're going to go to the one that has 2 places after the decimal place, right? So instead of 1.1686, we're going to go to 1.17. Okay, the exponent always stays the same during the rounding step, right? This should not change. Okay, and that's it. Right? Let's do a dividing example, right? Let's say we want to divide these two. Again, multiplying, dividing, we can rearrange them, right? So let's put the 1.89 and the 7.56 together, and the 10 to the 5th and 10 to the 2nd together, right? When you divide these two, you're going to get some nasty decimal number. Okay? For the 10 to the 5th over 10 to the 2nd, remember when you divide two numbers, right, and they have the with two numbers with the same base and different exponents, you are just going to be subtracting their exponents. So 5 minus 2 is 3. Okay? Next step, right, remember if we are going to be dividing, we need to first put in scientific notation, right? So this is 0.25. We need to move this decimal place over 1, right? That makes this number bigger. So we need to make this exponent go down 1, right? Move this 1 over, move this down 1, right? So 2.5 times 10 to the 2, right? And now we need to round, right? If we look back at our two numbers we started with in scientific notation, we see that they both have the same level of precision. They both go out to 2 decimal places. That's nice. Notice that this number only goes out to 1 decimal place, right? It might be tempting to say, oh, well, I guess we're done now. Actually, you're not. You actually need to add a 0 here, right? When I say the same level of precision, I mean the same level of precision. It needs to have the same number of decimal places. If you say 2.5, that implies that you did not measure past the 5, right? But we actually do have, according to our first two numbers, we do have enough precision in our first two numbers to say that this is 2.50, right? We don't want to leave our reader wondering, I wonder if this was actually 2.51 and they rounded to 2.5, right? No, we actually know that it was 2.50. Okay? All right. So just to recap that algorithm, you put the two numbers in scientific notation, rearrange the numbers you're working with, like so, right? And multiply. Then put your final answer in scientific notation, then round. So try your hand at these two and put your answers on the form. Hey, y'all. Sorry for growing a beard all of a sudden. There was a typo on one of the solutions from the last time I recorded this video, so this is just me correcting that. So here are the actual solutions to these two problems. Let me know if you have any questions on those. We'll talk about it in class on Monday. Bye.